Dear students, in last class we have studied relationship between line voltage and phase voltage in a star connected three-phase balanced system. In today's class we will study relationship between phase and line currents in a delta connected three-phase balanced system. Let IRY equal to IBR equal to IYB equal to IPH the phase currents. IB equal to IY equal to IR equal to IL line currents. VBY equal to VYB equal to VBR equal to VPH phase voltages. VRY equal to VYB equal to VRB equal to VL line voltages. In delta connected system, phase voltage and line voltages are equal. We have to derive the relationship between phase current and line current. So first let us draw the circuit diagram and phasor diagram. So in this delta connected balanced three-phase system, I have shown phase currents, phase voltages and line currents. It is delta connected balanced system. Next we will draw phasor diagram. IYB, IRY and IBR. These are the phase current phasors here. Angle between each of these currents is 120 degree. In the circuit diagram, if I call this point as X, applying KCL at X, we get sum of outgoing current equal to sum of incoming current, that is phasor sum of IR and IRY will be equal to IBR, or line current IR will be equal to IBR minus IRY. Which means that to get IR from IBR, I have to subtract IRY. And to subtract IRY from IBR, I have to reverse the direction of IRY so that it becomes negative. And then I will add IBR and reversed IRY to get IR. So it is now reversed IRY. I will call it as minus IRY. To add minus IRY and IBR, I have to complete a parallelogram taking minus IRY and IBR as the two adjacent sides of a parallelogram. This way. You can call all these as phasors here. By putting arrow marks over their heads. This is IBR and this is equal to IRY with negative sign. If I get the diagonal, then that diagonal will be equal to line current IR. Let us call this common point as O, and name this parallelogram as OA B C. In this parallelogram OABC, we are having OA equal to AB equal to BC, because we have written in the beginning IRY equal to IBR equal to IYB, that is all phase currents are equal. So parallelogram OABC becomes now a rhombus. In a rhombus, diagonal bisects opposite angles. That means angle AOB will be equal to angle COB. So we will show angle AOB and angle COB as 30 degree each. Angle AOC is equal to 60 degree here. Why it is so? It is so because angle between IRY and minus IRY is 180 degree. Angle between IBR and IRY is 120 degree. So 180 minus 120 will become 60 degree. Half of 60 will be 30 and 30 degrees. Since OA is equal to AB, triangle OAB will become isosceles triangle. And we know that in an isosceles triangle, altitude bisects the base. If I call it as altitude AN here, then BN will be equal to NO, or we can say OB will be equal to 2 times ON or 2 times BN. Now we will write the details about this parallelogram or a rhombus. In parallelogram, OABC, OA is equal to AB, AB is equal to BC, and BC is equal to CO, that is equal to IPH. Therefore, parallelogram OABC is a rhombus. In a rhombus, opposite angles are bisected by diagonal. Therefore, angle AOB is equal to angle COB is equal to 60 degree divided by 2, that is equal to 30 degree. In triangle OAB, OA is equal to AB. Therefore, triangle OAB is an isosceles triangle. In an isosceles triangle, altitude is bisector of base. Therefore, AN bisects BO, or we can say BN is equal to ON. Instead of using this property of isosceles triangle, you can also make use of property of rhombus. That is, in a rhombus, diagonals bisect each other at 90 degree. Now in triangle OAB, angle AOB is 30 degree. Therefore, cos of angle AOB is equal to cos of 30 degree, that is equal to ON upon OA, or root 3 by 2 is equal to ON upon OA, which means that ON is equal to OA into root 3 by 2. OA is IRY reversed. Here I will take only the magnitude of IRY, not the direction, right? So into root 3 by 2 we will write here. That is equal to ON. Multiplying on both sides by 2, we get 2 times ON is equal to 2 times IRY into root 3 by 2. Now 2 and 2 will get cancelled. We know that 2 times ON is equal to OB. So OB is equal to IRY into root 3. But OB is equal to line current IR. So IR is equal to root 3 times IRY. Since all line currents are equal to IL and all phase currents are equal to IPH, we can write IL is equal to root 3 times IPH. Dear students, I will stop the class here and continue in next class with the power relations in three-phase systems. Thank you.